All right, today we're going to talk about how to write an equation from a graph. So notice we have two different ones, so I want you to be able to recognize these. So this is an absolute value function, more of a V-shaped graph, and then we have a U-shaped graph for a quadratic function. So this is x to the second power, or x squared. So first, let's take a look at our absolute value function. So remember, the parent function here is y, or f of x equals the absolute value of x. If you write y equals, that's fine. But what I want to look at is how are we shifting left, right, and how are we shifting up and down. And so normally the vertex starts here at 0, 0. But notice that we have now traveled from 0, 0 to the right 2 and up 4. So what that does within our function, within our parent function, is we're going to go ahead and say y equals. We have no vertical stretching or shrinking. This is a standard graph, so that means a is 1. So absolute value of x, we're going to leave a space. This is our horizontal translation. So horizontal occurs on the inside of our function. Vertical translations occur on the outside of our function. Now let's just deal with outside first because it's easier. So notice how we are going up 4. So we've gone right 2 and up 4. Because we're going up 4, we are going to say plus 4. Now we went to the right 2. Now right, you think, oh yeah, that's positive. So right 2, I'm going to go to the right, to the positive x values. And you're right and wrong at the same time. This value is 2, but as part of our formula, we have f of x would equal absolute value. It'd be x minus h, or whatever symbol that your teacher may use. And then on the outside, we would say plus k. Again, some people use a, b, c, and d. Some people use a, b, h, and k. It just depends on your teacher. So in this case, because the formula has a minus sign in it, we have to say x minus 2. So it's almost backwards from what we would normally think of it. So because we're going to the right 2, we would say x minus 2. If we were going to the left 2, what would happen is, oh, left, negative. You would get minus a negative, and then we know that two negatives make a positive. So this would be the equation of this. Now, what do you notice that's different? This is not a V shape, a typical shape that opens up, but this opens down. That means it has been reflected about the x-axis. And so we need to put a negative sign out in front, showing that we are flipping or reflecting over the x-axis. Now let's deal with maximums and minimums. So here, we don't have any minimums. We have one maximum. This is the highest part that our graph reaches. And when we're talking about maximum, we're looking vertically, so our y-axis. So our maximum, the highest point this graph gets in terms of y value, is going to be 4. So we could say our maximum occurs at 4. If you wanted to put the coordinate point in, if you wanted to say it's 2, 4, I guess when in doubt, go ahead and put the coordinate point and you won't be wrong. Now, dealing with end behavior. How we write this is as x approaches infinity, so as our x values are getting larger and larger and they approach infinity, so we have 1, 2, 5, 10, 100, a million, whatever. What is our y value doing? So what is our graph doing? Our graph is going down, right? So as x gets larger and larger, our y value is getting smaller and smaller. So as we go down, we're saying this approaches negative infinity. And then now looking from right to left, as our x values approach negative infinity, as we get smaller and smaller as we move to the left, the graph is going down still. So we say we approach negative infinity on the left-hand side, left bound as well. So end behavior is looking at your arrows. Think of that as like arrow function. We're looking at what is the end of our graph doing in this case. Now, what about the second equation? So this is a quadratic, and so the parent function here, I'm going to use g of x. Parent function is just x squared. Now, if we have something on the inside, similar to that one, we would say we have parentheses, x minus h squared plus k. So when we are looking at our vertex, you have to be careful of our scale here. 2 blocks is really only 1 tick mark. So it's a half with each step here. So we're actually only going left 1 and we're going up 2. So we have to pay attention to the scale here. So we're going left 1, up 2. Well, vertical is easier to deal with. That's on the outside of the function, represented by k up here. And so this function opens up. It's a U-shaped graph, so we don't have to worry about the negative out in front. So our equation, we're going to say g of x is equal to x, I'm going to leave a space, so x minus, because that's part of that formula, and then we're going up 2, so I'm going to say plus 2 on the outside. Now we're going left 1, so some of you are like, oh yeah, I know this is negative 1. Well, you're right, but because of the formula, x minus a negative, when we have minus a negative, we can make that positive. So this is x plus 1 squared, because it's quadratic, and then plus 2. So we're saying we go up 2, but we go left 1. So it's almost opposite of how you would think of it. Now what about minimum and maximum here? In this case, we have a minimum. I didn't clarify that. You want to circle that, maximum, on the first problem. But here we have a minimum. So this is the lowest that our function is going to go. And the lowest y value our function hits is going to be at 2. But again, when in doubt, if you would like to do the coordinate point as negative 1, comma 2 for the vertex, or for that extrema, then you can. Now what about our end behavior? Notice how we're increasing on both ends. So as x approaches positive infinity, y is approaching positive infinity. And as x is moving left forever, y is going up forever. So both of these are going to be positive infinity.